Thank you, Juan. Yeah, so hi, folks. Welcome to the newly christened Urban Ideas discussion series. This particular panel is focused on sort of building scale analyses and questions, some focusing on urban energy use, the drivers of urban energy, and then also building level observations and inferences on socioeconomic characteristics. Melissa, you can go to the next slide. Some of the folks here might be new to the multi-sector dynamics and the multi-sector dynamics community of practice. So next slide, Melissa. The multi-sector dynamics community is an effort sponsored by the DOE to sort of accelerate development of capabilities through open science and growing a diverse transdisciplinary workforce in the space of understanding multi-sector dynamics. Now, your next question might be, what is multi-sector dynamics? Next slide. Oh, so the sort of MSD community is organized. There is a science steering group of about 15 people. There are also some working groups, a facilitation team, research sponsors, and specific MSD funded projects. Next slide. So there are 8 working groups. This series is organized by the Urban Systems Working Group, but there are other ones on research to operations and early career development, equity, modeling human systems, energy transitions and uncertainty quantification. Next slide. The Urban Systems Working Group is chaired by me, Krista Brailsford at Los Alamos National Lab, co-chaired by Puya Vamani, a research scientist at Lawrence Berkeley National Lab. Melissa Allen-Dumas, who is today's facilitator, is the communications coordinator for the Urban Working Group. Next slide. Within the Urban Systems Working Group, we've existed since 2020. We organized a big workshop in 2021, and then just last week, the paper that resulted from that workshop was finally published in Earth's Future, where a lot of the goal of this working group has been to understand how we think about urban systems research. Next slide. So for the rest of this panel discussion series, this month is energy use. January's panel discussion will be focused on flooding, and through the rest of 2025, there will be, or for the first half of 2025, there will be another series of panel discussions. Next slide. Okay, and now I'm going to hand it over to Melissa to talk more specifically about what we're aiming for today.
Okay, yes. So what we'll do is we will have 3 different panelists here. We'll start with Melissa Adrian, and she represents the CROCUS Urban Integrated Field Laboratory, which is in Chicago, or basically located in Chicago. Then we'll go to Anna Kato, who is representing the Southwest IFL, which is located in Arizona on an urban corridor there. And then we'll finish up with Nathanael Rosenheim, who's representing the Southeast Texas IFL, and that is located in, you guessed it, Southeast Texas. And so each of them will discuss for about 5 minutes the work that they are doing within these integrated field laboratories, and then we'll go into a larger discussion with the rest of the group. I have a few questions that I would like to ask them first, just to kind of get us some answers, to kind of get us oriented around what these urban IFLs are, and then some of the different things that the IFLs are trying to do. I'll see if they will discuss with us how their work fits in with those goals, and then we'll open it up to the rest of the group. So let's start with Melissa Adrian, and if you could also give us the affiliation to the institution that you have as well as you start your presentation. And I'm going to go to your slide now.
Sounds good. Thank you. Okay, so first of all, thank you so much for inviting me to speak on this. Just first to introduce myself, my name is Melissa Adrian. I'm a 5th year PhD student at the University of Chicago in the Department of Statistics, and I'll be talking today about work that's in affiliation with the community research on climate and urban science group at Argonne National Lab. And so the overall goal of this work within CROCUS is that we want to place sensors optimally throughout the city of Chicago in order to measure key variables of interest, particularly weather, throughout Chicago. And so if I could draw your attention to this little graphic that I've put on the slide. So we'll we have like a pipeline to test sensor configurations throughout Chicago. So this pipeline goes that we can collect information from these weather measure or from the sensors throughout the city. And though these sensors are kind of sparsely placed throughout the city, and you have gaps in between where the sensors are, this still provides information for locations that aren't actually sensed by sensors. And so we can apply some sort of interpolation to get a more complete estimate of key weather variables throughout Chicago. And from this kind of provides us a real-time estimate of, temperature, humidity throughout Chicago, to which this information can be put into a predictive model to predict key quantities that we're interested in Chicago. For example, we are particularly focused on predicting, for example, like heat vulnerability index throughout the city, and also energy consumption via air conditioning. And so we have simulations of all of these processes. And I have an arrow drawing from, predicted AC back to the sparse weather measurements, because it sort of represents that this is an iterative process of our optimization. We sort of have a sensor configuration, we try it out, we have some sort of prediction of what the energy consumption is, and then we can iteratively go back and move the sensors in order to kind of optimize our predictive performance at the end of this pipeline. And so this optimization routine is going to be subject to numerous practical constraints. First of which is that given the limited resources, limitations on resources to actually place sensors, we want to get the most information out of this. So we want to learn the most out of the least amount of resources. Second is that this is going to be like we're going to have kind of equity constraints, so that we want to provide kind of high quality inference throughout all of the city, but we particularly want to focus on areas within the city that maybe are vulnerable to heat stressors, and make sure that the sort of inference we provide there is as of high quality as other places in the city. And then obviously we have a maximum budget that we can't exceed for this kind of project. So these are sort of the constraints. The outcomes of this is that this optimization process will lead to kind of efficient data collection within the city. And this pipeline allows us to take sparse information that's collected in real time and be able to transform that into an outcome of interest. So specifically, based on real-time weather patterns, what's going to be the AC usage, the energy usage throughout the city. And so we want to kind of package this up into a tool to give to communities, so that they can take this sort of real-time information and assess impacts on their particular community. So for example, if we have a heat wave throughout the city of Chicago, and the predictions are that, specific areas are maybe underutilizing AC for whatever reason, communities can look at that and say, okay, maybe there's the opportunity to introduce some sort of mitigation strategy. So for example, assess the need to open cooling centers in particular communities. So that's kind of the broad overview of the project. Thank you.
Thank you so much, Melissa. We really appreciate that. And I know we've probably got lots of questions from people, lots of questions forming, but let's go into the next speaker. Let's go on to Anna. And at the end of all three, then we'll start taking questions. So go ahead, Anna.
First of all, thank you for inviting me as a panel. I'm again Anna Kato. I'm originally from Japan. I am a postdoc working at Northern Arizona University at Garni Lab, Professor Dr. Kevin Garni. So our lab has been working with Southwest IFL project. So especially our research topic is focusing on anthropogenic human-caused emission estimation and mapping. So we have two big projects called Balkan, which is the US National fossil fuel CO2 emission estimation and mapping project. And we have another one called HESTIA project. This one is more city specific. We utilize localized data to estimate asset scale, which means road segment, building scale, direct and indirect emission at hourly temporal resolution down to asset scale. So anthropogenic emission include different variables. The first of all, direct emission, just combusting fossil fuel, and then CO2 emission is happening. We also estimate indirect emission, which is emission by consuming electricity. Also, we are working on anthropogenic heat estimation and started working on air pollution estimation by combusting fossil fuel. Going to the top right box, the approach is a little bit hard to explain in 5 minutes, but basically we have a lot of efforts on data collection. So we have millions of different data sets from EPA, EIA, Federal Highway Administration, FEMA, blah, 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 which has different temporal information and also spatial information with different level of detail about emission type, fuel type, technology type, blah, blah, blah. So we just need to harmonize everything to get asset scale emissions. In particular, for HESTIA modeling, we try to get localized data from city, county, or local department of transportation to accurately downscale the emission into asset scale. So going down to the outcome box, which is bottom right, we have 2 different products that can be useful for the stakeholders or any users, researchers. One is the native resolution output, which could be provided as point, line, polygons. This example shows emission from different emission sectors related to building. One is commercial, another one is residential, lastly industrial. We also create gridded product. This one is more useful for modelers, for example, like atmospheric modeling. They don't use polygon line points data. They need gridded data set for their input. So basically this is what we are producing in the HESTIA project. So lastly, why we need to care this asset scale building emissions. The most important part is HESTIA is city-specific project, and cities globally account for 70% of greenhouse emissions. Building sector accounts for roughly 30% of energy-related CO2 emission. This is not really small. And more frequent, intense, extreme weather events because of the climate change or whatever will likely increase the energy consumption from building sectors. So providing this data could contribute to better understand the emission hotspot, and maybe cities or counties can develop better climate action planning. So yeah, this is basically the overall overview of what I'm working on at Northern Arizona University and SWIFT project.
Thank you so much, Anna. Really appreciate that. Let's go on now to Nathanael.
Thank you. And it's fun to see how everybody's interpreted how to convert these slides into the presentation. So my name is Nathanael Rosenheim. I'm part of the Southeast Texas Urban Integrated Field Lab, and I'm a research professor at Texas A&M University. And this work that I'm presenting is part of a project that I've worked on for many years now, and specifically looking at how to understand the disparities in resilience. And to understand those disparities, researchers must combine population hazard and impact data And this issue of data integration is not easy. We've seen several examples in the last 2 slides of different scales, different geographies, trying to combine these different disparate data sets together. And one of the things that's often left out in these combinations is the people. And one of the efforts that I work on is, as an urban planner, is making sure that people, businesses, jobs are well represented in our models of community resilience. The approach for this historically is taking census data from the U.S. Census Bureau. There's the decennial census, which is done every 10 years across the United States, as well as the American Community Survey. And this data provides our communities with a baseline for population. However, these data are provided in what's very complicated set of possible geographies. And there's lots of different geographies. The most common one is census tracts. And the approach that we use is to try to disaggregate this information, transform the data into housing units, and then link those housing units to individual structures. So we see on the right here an example of how census tracts have very unusual geographies. And for our team specifically at Southeast Texas, we're looking at issues related to air pollution and flooding, and those boundaries don't exactly line up with how the census tract boundaries. So what our effort is to simplify the data integration through what we call as housing unit allocation. And this explores how people are impacted and by any mappable hazard, risk, and or building level impact. The data that I'll talk about a little bit more is actually provides details not just on the number of people, but within each housing unit, the race, ethnicity, tenure status, income level, age, sex of the people within the house. Why is this important? Oftentimes underserved communities experience greater hazard burdens and slower recovery. And to change this issue requires evidence, and evidence requires good data integration. One theoretical approach that we have over here on the bottom right is looking at how before a disaster, we have pre-existing vulnerabilities, inequalities. The impact, whether it be a chronic or acute impact, often leads to damages, health damages, physical damages that are increased and exacerbated after the hazard. And then over time, while some parts of the population might recover fairly quickly, other parts of the population may not recover at all after many years. So I took a bonus slide. So in my last minute and 15 seconds. So this is just an example zooming in on one of our areas of Southeast Texas. This is Port Arthur. The Gulf of Mexico is just to the south of this. And to the north, we have many of the largest oil refineries, and part of this area is the petrochemical capital of the United States. The picture that we see over on the far right is of a group of kids playing basketball just in this particular study area. And you can see the oil refineries just in the distance. The points in this map are housing units, households, and they're color coded by what we have as equity flags. If it's 0 equity flags, that would be considered a white non-Hispanic homeowner that makes income that's greater than the median income, $45,000. And the dark orange dots are representing households that are minority, renter, and low income. So we have, for this part of Port Arthur, a very clear concentration of potential equity issues with low income renters and minority populations making up a significant percentage of this region. And what we were able to do is use this information to provide our community partners details on the population, poverty, income, and how the compounding factors of intersectionality of these characteristics. And if you're curious, you can scan the QR code and run this model for any county in the United States. I took up an extra 30 seconds. Sorry, Melissa.
Hey, no problem. Thanks so much, Nathanael. And thanks to everybody. Really interesting work going on here. So what I'll do now is I'll stop sharing the slides and ask a few questions that I'd like just each panelist to answer for their own urban integrated field laboratory. And I think we didn't really actually describe what the urban integrated field laboratories are at the beginning of this session. Many of you probably know because you are probably involved in them, but the Department of Energy has sponsored 4 different urban integrated field laboratories that involve some amount of observational data and some amount of modeling. And then maybe the most important part of these is the discussion with community groups to understand where they see the climate change issues are for their cities and what they would like to see the scientists study in terms of different problems that are associated with that. So with that, I'm going to just ask each panelist to just briefly describe the main objectives of your specific urban integrated field laboratory, and then how your research helps further the objectives of your integrated field laboratory. Let's go ahead and start with Melissa.
Okay, yeah. So CROCUS, again, stands for Community Research on Climate and Urban Sciences. And so this group is really focused on community-based solutions. Particular solutions are not going to work for every single community. And so it's just kind of finding out that the heterogeneity within the communities. And so there are 4 main goals of CROCUS that I'll outline. One is that CROCUS aims to develop new ways to sensor and monitor the environment. And these observations will be used as inputs to any sort of modeling efforts that want to be done. And so I most see my work aligning with that main goal. But in terms of the other goals of CROCUS, the second is to combine climate models with individual decision-making models. There's sort of kind of like a feedback between the two. So over the course of the next however many years, however many decades, the climate's going to change in a certain trajectory, which will impact, people in the communities. And those impacts will cause people to make certain decisions, and those decisions can actually, over the course of many years, impact climate. And so CROCUS is trying to kind of understand and model that coupling and, figure out trajectories that kind of lead us to sustainability goals. Third, again, I'll emphasize community. The community partners are contributing a lot to our research directions, and so we want to provide we want our work to benefit those communities like very directly. And then again, CROCUS aims to measure the impact of transitioning to clean energy sources. And so all of this, whatever is implemented in the city of Chicago, the overall aim is that other cities can maybe emulate sort of what sort of trajectories that we're going on. And so again, my research kind of aims to kind of monitor this environment. So yeah, thanks.
Thank you very much. Anna, how about your IFL? Can you tell us about it?
Sure. So I think the basically big picture is pretty much similar to what Marissa explained about CROCUS, but differences will be Southwest IFL. So we are in Arizona. Our main focus is how to settle down urban heat island issue. So heat mortality is quite high, as you can expect. But the interesting thing is, so I'm in northern part of Arizona. Heat is not the issue at all. So SWIFL, the interesting part is, so we are partnered with 3 different universities, 3 different research laboratories, focusing on heat in specific in Phoenix, Tucson, really southern part of Arizona, and also more likely air pollution or emission specific focus in urban northern part of Flagstaff, which I'm in Northern Arizona University. So likely, we will simulate what will be the emission, a future emission scenario will be. That is main contribution from our lab in Northern Arizona University, how to integrate human attribution to the anthropogenic, not anthropogenic, sorry, urban heat island. So yeah, there, of course, anthropogenic heat part is very tiny compared to big system, but there should be some impact just by driving a car, combusting natural gas for heating, blah, 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 how we can go sustainably deep in the next 50, 100 years. That would be a really interesting thing for us.
Thank you so much.
Mhm.
And Nathaniel.
So Southeast Texas, IFL, our main objective is to look at equitable solutions for communities that are caught between flooding and air pollution. And these represent acute on chronic hazards. We've also added recently, I think, to keep up with the other IFLs, the more of a heat component. We had a part of our IFL climate, but more climate, how climate projections are affecting flooding and air pollution, and we're also adding on looking at heat exposure as a additional chronic hazard. And then my research helps explore the distributional impacts of those acute hazards and social stressors across the socioeconomic spectrum, as well as looking at the access to the solutions. So how, if we do come up with various solutions, what's the access the different parts of the population have to those solutions.
Thank you so much. So I have a bunch of other questions I could ask you, but let me just open it up right now to the other people on the call and see if anybody else has a question, either for an individual panelist or for all of them, or whichever way you'd like to do that. Any questions from the rest of the people on the call?
I guess, Melissa, one of the things I was curious about is one of your slides you mentioned, or one of your little boxes, you mentioned that you were focused on optimizing sensor placement, right? One question is, I have a vague memory of like Argonne's array of things universe. And so question A is sort of, is your optimization interacting with their work at all, or is this a separate problem? And then the second question is, how are you thinking about the optimization problem?
Yeah, so I've like briefly heard about array of things. Basically, I think that, correct me if I'm wrong, it's kind of like sparse, or kind of placing like cheap weather sensors throughout the city to sort of kind of collect a bunch of information. And I think it might be open source as well. I could be wrong, but right now, my plans don't involve utilizing that, but I think like obviously in the future, like if we have access to that sort of information, you know, that would be kind of great to integrate that. And then in terms of the optimization process, optimize like this kind of like sparse placement is an issue that is like applicable to many different areas. So there's a bunch of different papers out about how to optimize to like sense something, whether it's, you know, engineering or whether it's space, throughout space or whatever. And it's kind of a challenging problem because the decision space is, you can't feasibly explore it. It's kind of like, for each location, do I place a sensor or not? And then if you have a bunch of different locations, that's a whole array of decisions to be made. And so kind of the approach that I've seen a lot in the literature, and probably the first step that I'm thinking about, is kind of making localized decisions. So, you know, placing one sensor at a time, like what's the next best place to place a sensor? And that sort of leads you to maybe a less than like globally optimal solution, but it's at least something tractable. So that's kind of where I'm thinking.
Questions from other folks? Okay, so while you're thinking of those, I'll throw another question out here, and I think this one is mostly focused on Anna. But I think probably all of you will have something to say about this. But what are the most important urban energy issues that are raised by the stakeholders in your communities?
Yeah, that is a really good question. But of course, stakeholder care. Am I going to die because of the heat or not? That is a really, really biggest issue for them. But of course, this related to the equity and also income level as well. So to reduce heat impact, they have to have really cool infrastructure, including AC or shaded structure or a reflective pavement or whatever. Installing those things require money, of course. You cannot change the environment, environment in terms of the nature. But you need to build and set up some urban infrastructure to cope with this heat. But at the same time, we just cannot construct or install new building because that's gonna increase more fossil fuel CO2 emissions. So that it ended up just facilitating climate change. More heat is coming in, temperature increase, heat-related mortality also increase. So this is a really bad loop. So we really need to think about how we can sustainably maintain the health level. Of course, the equity to provide cooling center or those can help to reduce heat-related stress. At the same time, how to meet with climate goal for the emission or air pollution perspective.
Thank you.
Mm-hmm.
Other panelists, would you like to weigh in on this question?
Yeah, I'm not sure if our urban energy issue is exactly, but we do have a pretty strong connection to our community, and we have a task force, and we just earlier this week on Monday, it feels a lot longer than Monday ago, but we had a meeting with our task force in Southeast Texas, and the task force includes mostly high-level decision makers across our region, some technical members, so people that are government officials working in things like drainage districts or industry, but also community members that are representing neighborhoods, churches, even a national park area. And for them, one of the things they would really like to see from the IFL is data that would help them improve their ability to get grants and funding. So, that in like what Anna was talking about, getting a cooling center or finding other ways to support the community to deal with the different hazards, providing them with information that they can then take to a funding source and say, this is how these resources are going to improve our community, and we can show a strong return on investment for those investment funds. So I think getting grant funding was one of the key things for our stakeholders.
I'll add that at least within the city of Chicago, some of the main issues that have been raised by the communities are, one, sort of the impacts of extreme heat. Two is in specific areas of Chicago, there are very intense flooding situations, which is overall not great. And then third, kind of relatedly, is people are concerned about the cost of energy. And so people are very interested in kind of reducing their energy consumption and also reducing the cost of, of their energy usage. And so I had mentioned before that like particular communities are interested in some things, but not others. So I'll give kind of an example. So in Humboldt Park in Chicago, there's been many people within the community that have talked about that they're interested in green roofs. So this is kind of like they're interested in installing that, you know, within the buildings of their community, and they're interested in that because it kind of can lead to an energy savings. And as another example, in Chatham in Chicago, this neighborhood has very intense flooding situations frequently. And so energy solutions that reduce energy in their neighborhood, maybe it makes sense to, you know, plant trees, because that kind of both reduces the kind of urban heat, but also helps with flooding by, you know, the tree uptakes water. So that's kind of an example of like solutions that Chicago is interested in. So
Yeah, thank you. Follow on by anyone from the larger group here.
So I guess I suspect it's already in your questions, Melissa. So I'm keeping my mouth closed and I don't need to jump ahead. But one of the things I'm really interested to hear from the three panelists is sort of how you see synergies and opportunities across the work that's been presented today. But if that's already on Melissa's question, don't answer it until Melissa asks.
Oh, no, go ahead. That's a good question. I'm curious what you have seen so far. Yeah.
Chris, to repeat your question. I'm so dependent on Melissa's nice, like pre-given questions.
Sorry.
I'm proud that these were pre-given. Really smart. Like, oh, well, I know the
the core question is, what synergies and opportunities do you see across the work that's been presented today? I see some, but I'm not the one who should be answering the question. You folks are the experts.
Well, if I would say, so of course, to reduce energy cost, maybe the new building structure that can, how they say, keep the really nice indoor environment is the better way to go. If someone is going to build new building infrastructure, but the question is constructing or adding new building infrastructure is the best way to go. That is another question. For example, in case of CROCUS, where I live in, so there are a lot of people coming from outside of the city just to escape from the heat from downwind Phoenix. So a lot of buildings are actually not for the city of CROCUS people. Those are for the people living in outside in certain season of the year, just temporarily staying in the city. Lots of beautiful pine trees, just cut it off, and then buildings are built up. It is actually the okay scenario to go. That is another question. So that is one point about switching to more how to say energy efficient building, newly built or not. Another thing is, of course, installing solar panels, windmills, rely on renewable powers. So a lot of buildings, houses already install solar panel on top of the roof. But of course, there are mega solar facilities exist across the Arizona. Well, Arizona almost 300 days, sunny days. So the solar panel installation and efficiency is quite high. But at the same time, there's some researchers going on installing solar panel will devastate native species or ecological status of that area. So what I'm going to say is, yeah, it's always tough to think about the future energy scenario. What would be the priority to think about? Priority to reduce the energy cost, priority to reduce the emission related to energy, or priority to the environment, like natural environment itself. I don't know if I clearly answered your question or not.
think probably in the different locations where you are, there may be some different priorities or different ways of having to think about implementing some solutions just because of the geographic and climatic differences across all of these areas. But I am kind of curious about the other two panelists, where you think the synergies are across the three IFLs.
I guess I'll just kind of briefly add something that like I noticed on like one of Nathaniel's slides. We're sort of talking about kind of integrating disparate information, like you had the census tract image and then maybe like the building level, like more granular information. And so that's kind of like an issue that also like CROCUS is kind of actively working on and investigating. So I feel like, you know, this is kind of just like one example of how maybe like different groups of people are working on kind of like similar goals, and maybe there's like opportunities to sort of like more so collaborate to, you know, create that synergy. So yeah.
I think kind of in that sense, all three of our presentations showed having very different data sets that have very different resolutions, and trying to bring all of that information together in a way that can inform a decision is I think a challenge, you know, trying and keeping track of, for me also keeping track of the uncertainties that are in each of those models, and trying to make sure that those uncertainties aren't lost as we try to communicate some of our what looks like a very very certain decision in the end, but you know, kind of, so you know, keeping track of some of the limitations of what we have.
Yeah, that is actually a really good point. So we try to provide our emission at different level of resolution. That could be a parcel level, truck level, county level. So the good thing is we have native resolution data at really low level resolution. I mean, high resolution. So we can easily aggregate into whatever census defined geographic extent. A lot of the cases from my Southwest IFL stakeholders, they care emission data or heat related data at truck level, just because their development planning is always happening at like down to truck level, or it could be bigger. But as you said, keeping track of uncertainty at different level is needed, but kind of hard to actually quantify. And the biggest task in near future will be when we develop a future scenario, there are 5 different scenarios and going to different trajectory. Is the uncertainty actually outside from one of each trajectory, or all of them eventually merge it into the same uncertainty? Whatever scenario is going, the level of the differences would be just within the uncertainty. Then it's not really informative for stakeholders. But yeah, you're really right. We want to know how uncertain it is when we produce any outputs.
And I'll just kind of add to that and say, I think that there are different aspects of this research that may be easier to quantify and may be easier to evaluate the uncertainty on than other aspects of it, which brings me to my next question, and that is energy and environmental equity and justice. I think that may be very hard to quantify uncertainty around, but at the same time, it to some extent is driving the research that we're trying to do here. And so I'm just curious how much those issues are driving the research that each of your IFLs are doing.
I think for the Southeast Texas IFL, one of the we have 3 themes. One is the environment, which includes air, water, and climate. And then we have a co-design theme, which is us, how our project is working with the community and co-creation of a lot of the moving of parts of the research. And then one of our themes is equity. So we have the, and our equity team has Krista's part of our equity group and has a strong connections with each of the other themes. So that for us, and we think of equity in the sense of looking at the distribution of impacts. So how do different parts of the community experience flooding, air pollution, or the issues of for climate change and heat, and seeing if there is a inequity in the distribution is one element of how we're measuring that. And then when it comes to resources, different resources, either resources that our IFL is bringing to the community, so sensors, new sensors, adding sensors to our study region, checking to see if the access to those resources is also what are the disparities in access, and then specifically looking at areas of the community that are underserved or underrepresented. We have a lot of fence line communities, so communities that are right next to the industrial plants and refineries. So that's an environmental justice issue. So we're all of those elements are integrated into our integrated field lab.
That's great to know how you're thinking about that. So yeah, thank you for outlining that. Other panelists.
Yeah, so our IFL is also working hard on it. And yeah, so in general, our IFL has 3 big groups. One is modeling team, one is observation team, and last one is resilience solution team. And this team has been working hard on communicating with stakeholders, local communities, and some researchers in this group is actually working on just visualize the equity in terms of income level or demography, and then come up with some air pollution or heat related stress or whatever. So I think to my understanding, first thing is just to understand the current environmental issue, hotspots, how they are spatially related to the current demography spatial pattern, just to understand everybody in the city is having the same level of extreme heat impact or pollutant or emission. Emission is hard because you cannot smell, you cannot see it. But pollution, heat, it's more easy to sense. So yeah, just to understand the current status of equity could be the really a starting point for us, I think.
Thank you.
I'll say regarding CROCUS's efforts, equity concerns are kind of like fundamental to kind of all the work that's being done at CROCUS. I think in terms of like my work, I'm trying to integrate sort of, for example, like there's the social vulnerability index that's published from the CDC that's available at the census tract level. So I'm utilizing kind of that information to kind of guide and assess whether the sort of whether I'm giving high fidelity, you know, inference and predictions to all of the city, but also particularly in the regions that need it. And so yeah, I think CROCUS also is actively engaging with specifically vulnerable communities to sort of map out how to best serve those communities, how, like, it's obvious that climate change is going to disparately impact people who are maybe low income, have limited access to resources. So CROCUS is involved in kind of mapping out the pathways for them over time.
Thank you. So I have heard all of you talk a little bit about different scales at which you are looking at some of these issues. And of course, it makes sense if you're doing an urban integrated field laboratory that those scales are within an urban context, maybe down to from household all the way up to the entire city. But I also know that we all are concerned with the global scenario as well with our work, and how do we start with what's going on in an urban setting and sort of understand how that ultimately affects things globally. So I will ask you this question. Do you how does your research, there we go, I'll get there. How does your research contribute both to the local and to the global urban sustainable or global sustainability goals? Some is urban sustainability, some is global sustainability. How do you see that, your research bridging those scales?
That's a good question. So in short, we are putting a lot of effort these days how we can, machine learn our model. So our current approach is more like really hard data integration, and US, as you might have known, is really rich in data. So it's relatively easy to get information, at least at county or state level, but if we can do all the analysis using satellite data or whatever data globally available, we can just test how the model is work at the local level, city level in US, evaluate the model, and then we can maybe help support cities outside the US to implement a model, even though they do not have their own inventory on that area. So it is a really standardized way to understand what is the emission status globally using the, systemized, standardized method. And if the area does not have any financial support or any research group working on inventory analysis or whatever, satellite data is getting more freely available across the globe. So it will also help them to develop their own inventory without spending a lot of money and effort on this emission inventory development.
I'll say in terms of the work I'm doing and also the broader context of CROCUS, there's kind of a push to make decision tools that are kind of lightweight. And what I mean by that is that you don't need like a supercomputer to run it. Currently, we have like multiple models of the climate, decision making, kind of heat transfer in the urban environment that are all based on very computationally intensive processes, like physics baked into equations. You run it on a supercomputer, wait, 24 hours and get something. And that whole process, uses a lot of carbon. And so by developing kind of a lightweight tool, based on, for example, like a neural network, there's going to be a whole, process of actually training the model. But as soon as those are trained, you have, kind of like a fixed tool that, you can kind of run on your laptop. And this is both kind of energy efficient, and also the fact that you don't need a supercomputer means that communities themselves can actually use the tool. And so that's kind of how we're thinking about larger sustainability issues. So.
I like that thought of how the lightweight tool can be, contribute to reducing our carbon footprint. One of the things interesting about Southeast Texas is that, and we're finding that in terms of distribution of impact and hazards and chronic stress, our region, it's a lot of the flooding issues or air pollution issues are felt pretty equally across the community. And what that actually creates as an opportunity is understanding how potentially households with the same exposure to, say, air pollution, how their income level or access to other resources might actually lead to different health and well-being outcomes. So as an example, does indoor air quality, if you have, what type of solutions and resources might be needed to improve your indoor air quality. And we might be able to see that more clearly in our study region, because we do see a lot of the same exposure to the hazard being across the community. So I think some of those findings I think will provide help for across other regions and be generalizable to show how health and well-being could be improved by improving indoor air quality. And I think that'll be an interesting thing that we're looking at.
Yeah, thank you so much. So we have 3 minutes left. And so let's take 1 minute per panelist to just say what you'd like for us to take away from this session. And then we'll all sign off and say goodbye. So let's start with Nathanael.
So well, thank you for organizing this. I look forward to the other panels and learning more about the MSD group. I think takeaway for me is I think it's interesting. I'm really interested in this data integration issue and seeing how this problem shows up across urban communities and dynamics of that. So I think that's an interesting issue that we all showed today in our presentations.
Okay, I go next then. So yeah, thank you for inviting me, and it was really interesting talk from different IFL groups. And my takeaway would be, so emission modeling seems like something unique that is happening in Southwest IFL, but hopefully maybe we can cross-pollinate across different IFL, how we can utilize this native resolution data set to improve or help support the decision-making tools each IFL is developing, or any feedback on like how the relationship between the air pollution, indoor quality with emission data or whatever. So just you're looking for lots of collaboration opportunity coming up if possible.
Thank you.
Yeah, thanks for having me. And I guess the takeaway I have, I'm sort of kind of new to the integrated field labs, and so I think the main takeaway, at least for me personally, is to kind of look at what all the other integrated field labs are doing. I think we're all working on like very similar but different angles of the same sort of issues. So I think like these conversations through these discussions are really useful. So thank you.
Yeah, thank you to all of you. And I remember now that I have one more slide we need to share with you. And this is, I'm going to let Krista talk about this. This is how you can stay involved in this group here.
Is there a second one of this, Melissa? Oh, I think I sent you the wrong version. Anyways, I'd made a version of this slide that had QR codes, but one can stay involved with the MSD community by signing up for both the MSD newsletter or the Urban Working Group emailing list, which you can find if you go to multisectordynamics. It's either .com or .org, sorry. But you can sort of find the website and click around to get to the Urban Working Group and sort of find the way to join the newsletters, which is a good way of keeping track of the ongoing development of the panel series.
All right.
And yeah, thanks everyone.
Yeah, thanks everybody. Really enjoyed this discussion and look forward to seeing you at future panel discussions as we go. Thanks a lot.
Thanks,
Bye-bye.
everybody.
Thank you.
Thank you.
Thanks, Juan.
Of course.